Hello and welcome to section 5.1 about domain and range. This section is about function notation. And function notation we introduced back in chapter 1. We've been using it here and there throughout the class. But if you are struggling with this, I recommend going back and looking at like section 1.1 or 1.2 notes where we went into a lot more the basics of what y equals f of x means. So with that in mind, let's look at this definition of domain. This is something that gets used a lot in trigonometry, pre-calculus, and calculus kind of all the time. And it's an important concept. So let's see. The domain of a function y equals f of x is the set of input values for x for which f of x makes sense. And what do we mean by makes sense? Well, let's look at some examples. So with example 1, we want to find the domain of these functions. So the first function is f of a, so the input is a, and the output is the result of doing a divided by 350. This function is used to calculate the number of gallons of paint needed to cover an area of a square feet, I probably should have said. So what makes sense for the domain here? Like you could find f of 10, so that would be, you want to cover 10 square feet, you could just do 10 divided by 350, and you'll get a pretty small number, about 0.286. So you only need, oh, I'm missing a zero here. You only need a small fraction of a gallon to cover 10 square feet. So you can't buy that precise amount at Home Depot or anything, but that's still an amount of paint that exists. So it kind of makes sense. You could do f of 1,000 square feet, like you need to cover a few walls of a big house. That's going to come out to be 20, or no, not 20, 2.86 gallons, and that's a lot too. You could do 0. 0 is a value of the input a. That makes sense here. You're just going to get 0 over 350, which is 0 gallons. So if you need to cover 0 square feet, that makes sense. You can cover that with 0 gallons of paint. Okay. And the cost of it will be $0. And the distance you have to drive to go to the hardware store is 0 miles, and that's fine. But what about if you have f of negative 10 square feet? I mean, you could plug it into the formula and you'll get negative 0.0286 gallons, but negative square feet don't really exist in this universe. It doesn't make sense. So that's what we mean by something that doesn't make sense. So any negative number here doesn't make sense as an area of a wall. So the domain is going to be only values of a, the input values that make sense here, and that's going to be a is greater or equal to 0. Okay, so that's the domain that makes sense here. Now in part B, the function c of n equals 0.48 times n. This gives the cost of purchasing n postage stamps. So for example, if you want to make n equal to 0, that's the cost of 0 postage stamps. You'll get 0. If you want to know the cost of 1 postage stamp, that's going to be 0.48 times 1 is just 48 cents, or 0.48 $6. And if you want to buy 100 postage stamps, that's going to be 0.48 times 100, which is going to be $48. Okay, so those all make sense. But you can't buy negative postage stamps. Like if you want to buy -3 postage stamps at the post office, they're going to say, sorry, sir, we don't sell negative postage stamps here. All of the numbers of postage stamps that we have is positive. You're going to have to go to the opposite of a post office, whatever that is, to buy the opposite of postage stamps. So this doesn't make sense. What about if you want to buy 2.5 postage stamps? So if N is 2.5, we're saying we want to buy 2.5 postage stamps. They're not going to do that at the postage at the post office either. So you can have 2.5 square feet. That makes sense as an amount of square feet. But the post office is not going to sell you 2.5 stamps because half a stamp is worthless. So this also doesn't really make sense. So you can't have fractions of stamps. You can't have negative numbers of stamps. So the domain is going to be the values of n, whatever the input of the function is. In this case, it's n, that make it so the cost of that makes sense. And in this case, this is going to be n equals 0 or 1 or 2 or 3 or 4 or so on. Just positive whole numbers are the kinds of stamps you can have. So that's the way this works in a real life situation. You need to think about what makes sense in real life for that to work. But what if you just have a formula, like just a sort of abstract function like this? In this case, what makes sense is determined by the different kinds of arithmetic you can do. So let's look at this first one. F of x equals x cubed minus 2x squared plus 4. You can plug in any negative number you want for x into this. You're allowed to cube a negative number. You're allowed to square a negative number. You can plug in 0. You can plug in a positive number or a fraction. That's okay. Those are all things that you can multiply by itself and do this kind of arithmetic with. And you might want to see that by looking at something like Desmos.com. So here's this graph on Desmos. If you take any value of x here, you can see we might need to zoom out a bit. Any value of x that you want is going to give you a value of y on this graph. So there's no x coordinates here that don't have a y coordinate associated with them. And the ones that you can't see here, like out at -4, well, you just need to mess around with the graph until you can see it. Maybe zoom out a bit in this direction. And then you can see that any value of x is eventually going to give you a value of y. It might be really big, but so this has domain all real numbers. And that's what that looks like on the graph. Every value of x has something. What about f of x equals 5? So let's see. F of x equals 5 just says that no matter what you plug in for x, you're going to get 5. So if you plug in 2 for x, well, the formula doesn't say to do anything with that number 2. It just says the result is 5. So f of 2 is 5. F of -10 is 5. F of 0 is 5. F of pi is 5, and so on. And you're going to get any real number you can plug in. You're just going to get 5 as a result. So the domain is all real numbers. And you can see what that looks like when you graph it here. If I was just going to graph y equals 5, there you go. no matter what x you plug in, the y coordinate that you get is 5. There, you can see that's 5 there. Okay, so that's y equals 5. What about f of x is the square root of x? So this is a situation where maybe there are some x's that you cannot plug in. So if you, for example, want to do f of 9, you're going to get the square root of 9, which is 3. If you want to plug in 0, that's okay. The square root of 0 is 0. If you try to plug in something like negative 9, the square root of negative 9 would be something that you can square and get negative 9, but that's impossible because any negative number squared is going to be a positive number. Negative 3 squared would give you positive 9. So this doesn't exist. You can say it doesn't exist, or it's undefined, or it doesn't make sense. Those all mean sort of the same thing. So x cannot be a negative number, but the square root of x does make sense if you have any positive number or 0. So the domain is going to be x is greater or equal to 0. Right. Let's look at some more complicated examples. So what if you have 1 over the square root of t? Oh, and by the way, before I go on to part D, what I wanted to do is look at a graph really quick of part C. If you make a graph of y equals the square root of x, you can see over here that there are no points on the graph when x is a negative number over here. We only have output values when x is a positive number or 0 out here. You can see that 0, 0 is a point on it, but there's no output, no y value when x is negative 3. Okay, how about 1 over the square root of t? So for this one, well, we know that the denominator of this fraction is not going to make sense if t is negative. So t can't be negative because if t is negative, that would make the square root of t undefined. What if t is 0? You're going to get 1, so I'm going to do g of 0. You're going to get 1 over the square root of 0. And the square root of 0 is 0, so this is 1/0th. Which doesn't make sense. Anything divided by 0 is undefined. So that means that 0 is not in the domain either. But if you take any positive number, it should work. Let's check that by graphing it. If I do y, or you could write it as g of t if you want, equals 1 divided by the square root of t. And this is what the graph looks like. You can see if t is any positive number out here, you'll get a result for the output, a y coordinate. But if t is 0, well then the denominator, or let's say, first if t is close to 0, let's see. If t is something like 0.2 or 0.1 or 0.05 here, then what's happening is the outputs get bigger and bigger. But if t is equal to 0, there's no actual point there. It just gets closer and closer to where t equals 0, but g of 0 is undefined. So that's what that looks like in a graph. So the domain is only positive numbers. Greater than 0, but not equal to 0. All right, how about this one? H of w is 1 over the square root of w minus 3. Well, this is kind of like the one before. It's just that instead of just the square root of t, you have the square root of w minus 3. So, just like with this one, the thing inside the square root in the denominator, that has to be positive. So I could just write this as saying the domain of this is going to be w minus 3 is greater than 0. Because whatever values of w make it so w minus 3 is greater than 0 will make it so you're allowed to do the square root of that positive number and then divide by that result. So if you want to know what w's make this work, just add 3 to both sides to get w by itself. And that's going to give you w is greater than 3. And so if you're not sure about this, you could always graph it. Let's do that real quick. Okay, so now I want to see what this looks like here. I'm going to zoom out again so I can see 3 here. And you can actually see that the graph of h of w here is in green here, and the only x values that make it so there is a y value as a result are at x equals 3 or greater, or w equals 3 or greater. So you can see how these are kind of the same thing. It's just that h of w ends up shifted to the right by 3, which is kind of interesting. So that's the domain of this, is w is greater than 3. Now how about this one? We want to do f of t is 4 minus t divided by t squared plus 5. So let's see. The top, 4 minus t, you're always allowed to do 4 minus a number if you want. The denominator is what you might have to worry about, because anything divided by 0 is undefined. So if t squared plus 5 is equal to 0, that will make this thing be undefined. And so what values of t make t squared plus 5 equal to 0? Well, t squared is always positive, and if you add that to 5, you're going to get something that's always bigger than 5. So this has no solution. You could also find that this has no solution a few other ways too. Oh man, this mockingbird is so loud. I'm sorry about it. I can't make videos inside because I got the rest of my family in there doing their work, and they're also making noise. And then when I go outside in our neighborhood, we have the loudest mockingbird in the world. And I see now sort of where they got the phrase "to kill a mockingbird" from, because I think a lot of people want to kill a mockingbird because they are so loud. Anyways, so t squared plus 5 has no solution. T squared plus 5 equals 0 has no solution. So there's no way to make the denominator 0, which means that this is always going to be defined. So the domain is all real numbers. All right, so let's look at what this graph looks like. And f of t equals the fraction t plus, wait, it was 4 minus t divided by t squared plus 5, right? Yeah. Okay, so here you can see the graph. I'm going to zoom out so we can see the shape a little better. It's kind of a weirdly shaped graph, but as you can see, no matter what t value you pick, there's always going to be some y coordinate that comes out of that. So the domain is all real numbers. Right, what if it's t squared minus 4 in the denominator? That's a little different. Can we make this undefined when t squared minus 4 is 0? Let's try to make that happen. So if you want to solve this equation, well, actually, you got 0 on one side, and the left side you can factor into t plus 2 times t minus 2. And if you don't believe me, it's a good idea to pause the video at times like this and FOIL everything out, make sure it works. What t makes t plus 2 equals 0, that will give you t equals negative 2, and t equals 2 will make this one 0. So those are values of t that will make the denominator be 0, which makes the whole fraction become undefined. So any other value of t should work. So I'm going to write this as that the domain is everything except what makes it undefined. So the domain is going to be t is not equal to negative 2, and t is not equal to 2. Okay, let's see what that looks like when we graph this function. So it's just like the other one, it's just going to be t squared minus 4 in the denominator. And I can see some weird things happening here. I probably want to zoom out a bit to get a better idea of what the graph looks like. And yeah, here you can see negative 4, negative 3, negative 2.5. All of these values of t give you some y coordinate as a result. Anything between negative 2 and 2 gives you a y coordinate as a result. But if you try to plug in t equals negative 2 or t equals 2, there's no y coordinate there. The graph gets really close to those values of t, but you can't actually have a point where t is equal to 2 or negative 2. So that verifies that. Okay, let's look at example 3 here to finish this video off. In the next video, we're going to look at the range of a function, but let's just do a quick review of using the graph of a function to get the domain. And I've kind of already been going over this concept with the other, with examples 1 and 2, but this is a good thing. So if this is the entire graph of the function y equals f of x, meaning this point, this point, this point, that's not part of the graph. Only the ones with the dots are parts of the graph. And there's only 4 points on the graph. So what are the x coordinates that you have? You have one at negative 1 here. You have one at 0. You have a point at x equals 1 and a point at x equals 2. So those values of x are what makes up the domain. All right, now what if you have this situation here? So this is the entire graph of g of x. It looks like almost the same kind of function. It's just that like it's probably the same formula for how you'd calculate the y based on x, but the difference is the actual points that you have. Here, you're allowed to plug in something like x equals 0.5, or x equals 0.2, or x equals 1.9. But what do these empty circles mean? The empty circles mean that the graph gets really close to the 0.25, but 2.5 itself is not actually on the graph. So, but 1.99 for x is on the graph, and I guess the y coordinate that you would get out of that is probably something like 4.9998 or something like that. So that is on the graph, is what that means. So the domain is going to include everything from -1 up to 2, but not actually including -1 and not actually including 2. So you would write that as x is between -1 and 2, like so. Okay, so let's do the range of some functions in the next video. I'll talk to you then.